Now, the last shape we're going to look at here is a lemniscate. And it's sort of a propeller shape is how you would think of it. And what happens is it's a slightly different form. You still have sine and cosine, and you still have that 2 theta, but you're squaring the r and the a. Now, the a you may not notice is always squared because that's just going to be a number, but you'll definitely see that r squared in the formula. And again, you'll see those 2 thetas. So when it's sine, you sort of have this diagonal propeller, and when it's cosine you have a left, here you have a left to right propeller. It's horizontal instead. So the a represents really that length of that propeller here. And these can again be kind of hard to graph, so let's try one example here. And again, it's always good to check with technology like I showed you in the last video. So here you have r squared equals 4 sine of 2 theta, and the first thing that's good to do is to just check for symmetry here. So for the polar axis, we're going to go ahead and replace the theta there with negative. So you end up with a negative 2 theta on the inside here. And remember, sine is not even, so that negative is going to come out. So it's negative 4 sine of 2 theta. And again, this is not the same as the original. So again, we just don't really know about the symmetry there. We're going to move on to the line pi over 2. Here we replace both the r and the theta with their negatives. Now negative squared is positive, so this still stays r squared, and that negative is still going to come out. So again, you don't see anything here for symmetry. So it's not the same as the original. And again, we just don't know what's going to happen with the symmetry there. So the last one we're going to test is the pole. And for the pole, you only replace the r. Now this one hopefully is pretty quick to see. When I square that negative, it becomes positive again. And you do have that it is the same as the original function. So we definitely have symmetry with the pole. Now remember, symmetry with the pole is like with the origin, it's a diagonal symmetry. So it's not going to be a left to right or up or down. You're going to see this diagonal symmetry in the graph. But we do need to go ahead and make a table. So I've already started the table on the next page. Now we're dealing with sine here. So remember, sine is periodic from 0 to 2 pi. And I've started going through the table. On the next page here. So I started by plugging in 0 first. And when I plug in 0, 2 times 0 is 0, and sine of 0 is 0. So the first one's pretty straightforward, where you get 0 for result. You do want to be careful though, because remember that this is not just r, this is r squared. So we actually have r squared equals 0, but that ends up being the same thing as r equals 0. So we have our first point here. When I go to plug in pi over 6, I have 2 theta, so 2 times pi over 6 would give me pi over 3. Sine of pi over 3 is root 3 over 2. And then I can cancel out the 4 and the 2 and get 2 root 3. But you need to be careful, this is not done, because the problem is not r equals, it's r squared. So you actually have that r squared is equal to 2 root 3. So I have to take the positive and negative square root of both sides there. So my r value is actually positive and negative 1.9. And the same thing would be continuing on. The next one I would do is what pi over 4 I could do. I'm going to do some extra points here as well, because these are getting kind of complicated. So 2 times pi over 4 is going to bring that down to pi over 2. And sine of pi over 2 is 1. So I have the value of 4 here. But again, don't forget, this is not r, it's r squared equals 4. So when I take the root, it's plus or minus the square root of 4, or plus or minus 2 on both sides. So you're actually getting 2 points for each of these. So as you're going through your table, except for 0, 0. So here I have the point, so far I have 0, 0. For this one, I have both 1.9 pi over 6, and I have negative 1.9 pi over 6. Here I have 2 pi over 4. I also have negative 2 pi over 4. So this is going to continue when I plug in all these points. So this one is a bit more complicated. To speed things along, I'm on the wrong section of my notes. Let's see. If we do pi over 3, again, I'll let you try this one at home. You would get that r is equal to plus or minus 1.9 again. So you have a very similar computation there. And then when you have pi over 2, and you do the work, you get r is equal to 0. So what we did here is we're just going to start by plotting these points first to see what you get. And then we'll kind of keep going. All right, these still take a little while to make. You think I would get faster at them, but this will take some time. Finally, the last one. Okay, so let's start by plotting what we have. I know I haven't finished all the points yet. I've only done a few of them, but we have quite a lot going on here. So let's see. So I have 0, 0, 0. And then let me do the positives first. So I have 1.9 pi over 6. So I gotta do my circles. Let's see, 1, 2, well, to 3, and 3. So I have 1.9, so almost 2 at pi over 6. So like right here. And then at pi over 4, I'm at 2. And then at pi over 3, I'm at almost 2 again. And then at pi over 2, I'm back at 0. So I have sort of this one petal coming out here. Now, if I do the other side here, if I do pi over 6, I'm at negative 1.9. So I'm on the other side here. So I'm like right here. And then at pi over 4, I'm at negative 2. So I'm on the other side here. And then the same thing for pi over 3, I'm at negative. And the other thing you want to remember too is, remember we said that we had symmetry with the pole. That means you have that diagonal symmetry. So you're going to have that same sort of petal on the other side. So you can see that both from the symmetry part that we did, but also from this plus or minus, that you're getting that, that diagonal reflection there across. So you have that symmetry with pole. Now, you're not quite done. So remember, you have two sides here, but you haven't filled in anything for pi over 2 to pi. You could also use a symmetry going the other way too, because it's diagonal. So if I know what happens in quadrant 2, then I can figure out quadrant 4, because they would just be mirror images. So what you could do is you could start plugging in points here, and you'll see that it's not going to quite work. Or what you could do is just think things through a little bit, which is what your book recommends here. So what happens is, let's say we start doing our values here, plugging in 2 pi over 3, etc. For our thetas. So these would be our thetas. Well, don't forget, you're not just plugging in theta, you're actually, it ends up being 2 times theta. So if you're multiplying these by 2, then it's going to be either in the third or fourth quadrant over here. Once you plug those in. And what happens is that in the third, quadrant. All right, so what happens is in the third quadrant, sorry about the pause, I had a tickle in my throat. When you're in, so when your theta is in the second quadrant, then 2 times theta is going to be somewhere bigger, right? It's going to be in the third quadrant or in the fourth quadrant. And what happens is that sine of 2 theta would then be negative, right? So the sign represents the y piece. So if you're over here or here, then that sign is going to be negative, which is fine. There's nothing typically wrong with that. But if you look at your equation, that means sine of 2 theta would be negative. And so 4 times sine of 2 theta would also be negative. But the left side is an r squared, which has to be positive. So if you start plugging in values, or if you just think about it a little bit, you're going to see that we actually don't have to keep going, because it's not going to make sense. our theta is going to get pushed below the axis. So our sign values would be negative, which doesn't work with an r squared. So this is actually the entire graph here. And again, you can check this. You can always plug in more points if you're not sure. That's sort of my go-to is if you're not sure, you don't really know how to use the symmetry, you're kind of getting stuck there, just plug in more points. Go from 0 to 2 pi, see what happens. And then also use your technology to check your answer.